I'm Nili. I love mechanical engineering, but we do kind of a little bit of everything. In particular, my lab, we focus on prosthetics and rehab robotics, and we kind of have two big things. So, how many of you have like seen Star Wars? Okay. Ooh, actually, not so many people have seen Star Wars. Genuinely surprised. But everyone's seen the Luke arm, right? You guys are all familiar with that. Unfortunately, that is not the current state of prosthetics around the world and in Israel. Most people have a split hook. And when we talk about leg, my hand slide didn't work, so I just skipped it. But when we talk about leg, this is the type of legs that the soldiers that you guys have heard of, the people around the world, diabetic patients. These are the $100,000 legs that people get today when they get prescribed a leg. It's really fun. You see how difficult it is for him to stand up. It's very difficult to climb stairs, etc. And it requires a lot of energy, metabolic energy, consumption. It's fatiguing to use these types of devices. So in my work, we work on arms and legs and improving them. In particular, our goals are sort of focused on these 4 areas. So design, building better devices, control, sort of how do we control them, how do we integrate with the person and interface with them, how to make the systems more autonomous, and take away some of the burden on the user. And lastly, neural control of movement, understanding how we move and use our limbs in control our movements from sort of a control theory perspective. So we see that we can build better limbs. This is the type of example of a leg that I worked on, that we're building lighter versions, but the legs that provide the ability to climb, to get out of stairs, to give people the energy that they currently don't have. But we need them to be more intelligent, more predictive. So we use a lot of machine learning, etc. But also we're working on the dynamics, how to optimize them for various different tasks, users, etc. We also work on understanding basically neural control of movement. How do people move? Can we predict their movements? Can we train models to predict both healthy and impaired subject movements, using a lot of different approaches? I kept this short. I hope that's good. And then lastly, can we use this is an example of my ARM project, but can we use shared autonomy and these different models to build better, more responsive systems that will operate faster? So this is an example where we showed a significant decrease in latency with our system versus regular arms to build more responsive systems that are based on natural movements. So in general, we kind of have to understand the user in the loop and build better robotic systems. Yeah, that's it. I went really short, so join my lab if you're interested. It's very new, but I have people, so you won't be alone. And I think we are coffee makers. That's all I got for you. We want to keep it short, and I think I did. Thank you. Question? Yeah, like a minute for questions.